Yes.
How do you determine the number of genes? So your device has a certain number of degrees of freedom. How do you determine the number of genes from that?
I'm not sure I know how to answer that question, but the genes in this case, there's only one gene per organism. In the GA terminology, there's the genotype and the phenotype. The phenotype would represent the gene, which is the behavior, plus the hardware itself. You sort of have to match it to the problem you're trying to solve. For tabletop, for example, I just assumed that each state, that this problem could be solved just by saying, if I'm here, I want to back up and rotate a little bit. And the first version of the tabletop I had, actually, when it found this, would back up for a certain number of milliseconds using negative, the same left and right. Then it would do a rotate. So there was actually more data involved. There was a backup speed, a backup duration, then a rotate speed and a rotate duration. So that would be a completely different gene. If it wasn't able to solve tabletop with that gene, then of course you have to give more state. Because if you don't have enough state to solve the problem, and sometimes that's a good question because sometimes you don't know if there's a solution or not to a particular problem. You just have to run it, and if it doesn't learn to solve it, then you have to give it more information in the state. Yes, Danny.
Do you have a way to read back out what the best stored genetic?
Yes, I do, and if it were hooked up to my laptop, it would print them out to the console. That reminds me, if anybody knows how to easily hook up a wireless serial connection to an Arduino, please talk to me because I would love to be able to get output without having to tether this to my laptop. So please see me if you have a simple solution to that.
XB.
Yes. Go ahead.
So it appears that there's a sequence of motions happening, and I'm not sure I see where the sequence is getting compiled here. It looks like there's just only one state of 4 possible values, right?
Yes, so what it does, let's go back to the fitness function. And the fitness is basically run for 5 seconds. So what we do is we take the initial time, it's like, okay, start the timer, and then while 5 seconds hasn't gone by, let's read the sensors. Let's see, what state are we in? And then just look up in the gene. So we get a pointer to, this is the state, we get a pointer to, here's the 3 values for the gene. And we're going to take the left value, the right value, send those to the motors. Here's some printing debug stuff that really doesn't need to be there. And then we delay, again, the value of what the gene is. So ignore the test code in the middle, but basically these 2 lines of code says, read directly the state, well, more lines of code. So read the current state, and based on that state, set the motors and the delay, and just loop. That's all it's doing. You have a question?
Yeah, sort of, kind of a question, kind of an observation. It looks like if you pop up a few thousand feet, essentially it looks like an example of heuristic design, where it's like you have the universe of random numbers, and you're going to have some sort of a filter that includes time, state, and you'll apply the filter to the numbers, and you're looking for a subset of those numbers coming out, a particular kind, and so you'll fiddle with the filter until you get the output that you want.
Exactly.
Okay, and the thing there is that by doing that, you have generated this control function, if you will, without having a mathematical model. And the flip side of that is, since you don't have a mathematical model, unless you can go through all possible states, you don't know if your design, you will not know when your design is complete. Because the design is complete when you've seen all possible states and you've prevented any bad states and captured all the good states, right?
Well, I'm not sure what you mean by design is complete, but I'm going to sort of rephrase that by saying Have we solved the game of tabletop? No, we have not looked at all the states. And so have we found the exact perfect solution? No, we have not. But again, as I said before, the whole point, the crux of all the AIs, including genetic algorithms, is to find a solution that works good enough.
Yep.
And then once you've found something that sort of works, hill climb and optimize it as best you can, but you will eventually fall into a local minimum. There's never a guarantee that you found the right solution. And that's the trade-off of AI. We can now solve problems that are much too big of a search space. And we get good results for it. All from randomness. It's actually a pretty cool algorithm.
Yeah, once you define the space.
We'll do 3 more, because I know we want some, what time is it? Okay, yeah.
So what would be the implications of introducing a random variable into this? So let's say this tabletop is a little bigger, and there were 2 bots, and the instructions were don't go over the edge, but don't run into the other one. Does that kind of kill the whole thing, or
It doesn't kill it. Again, the size of the gene will give you an idea of how many versions or iterations it's going to take to find a workable solution. You're going to need another sensor, because it would need to know, did it bump into the other guy? And let's say we added a ping sensor, and the ping sensor read a value, and if the value was less than 5, then that counts as a collision, and then it dies. It would eventually learn not to die, but the problem now is there's an external agent over which it has no control. And when that situation is a completely different situation, in that a single bot might not learn to do anything. For example, if we constantly shifted the pattern of what the table is, it's going to fall off, it's not going to find a solution. So in that case, I would imagine it might not find the right solution. It might find a solution to stay on the table, and it would still accidentally bump into the other bot, because I don't think it could learn to avoid it, because it's not in a fixed location. That's just surmising. I really don't know, but sometimes you find a program that you can't solve with a GA. And external variables beyond your control is a good example of you can't adapt to that.
so does that take you to different approaches then, using the other types of algorithms you talked about?
You could probably solve this by adding more and more state variables, but then you'd have to be clever as to what those state variables represent. For example, I've encountered this robot at 10. Now I need to move to back up away, because I sort of sensed him. I know 5 is a collision. So I think you could eventually adapt to that. Again, I'm just making stuff up. Other solutions might be better to this, like neural nets or Bayesian type of thing, where it could actually detect and predict the pattern of the other robot. Okay, we'll do one more question after this, and then
Just an observation. You had another sensor that will look for constant bearing and decreasing range, and do something about that. So the solution to some of these might be just adding sensors to be able to sense what's going on with this additional source of randomness. Like in the case of not sense everything about the other robot, but just that it's on a collision course with you.
yeah, that's true, which is why I said if you wanted to do that, you would probably need another sensor so that you could get range and bearing. And yeah, the solution to these is sometimes if a robot can't do something, you need another sensor, because if it's deaf, dumb, and blind, it's not going to, it's going to bump into walls. So, any more questions?
Show us where the file is.
Oh, yeah. Which file?
The Arduino code.
Oh.
Maybe could you resend the link on the list?
Let me go, let's see, homebrew,
And your
and
screen's not up.
Change your screen.
thank you. I think that times that. Here's the mailing list. And let's search for Motbot. Let's see, robot builds here. Here's how to make a Motbot. I think there's the link. looking at how to make a ModBot. And again, sorry for the slow connection. So here's some Arduino code. I have not put the genetic algorithm code there yet, but I will copy that in there tonight. But this is everything you need to know to build this, minus the middle extra third sensor. If you are going to play around with GAs, make sure you try to solve a problem that doesn't involve the destruction of the robot, or come up with a clever workaround. So we've got wiring diagrams. And next picture, you click that arrow, it should go to the next picture, but it's not. Oh, there we go. Detailed directions on how to build it, pictures of parts list, and code on how to get it working. So I'll add the genetic algorithm code. I'll actually also throw in a different link for the mini Watson stuff, because some people are interested in looking at the videos on it, learning how to do things. Unfortunately, I can't find the original VREP models and the code where Mini Watson actually learned how to walk. I know I have it somewhere, but I couldn't find it. So join the mailing list.
How do we join the mailing list?
Just go there. Click the link.
HBRobotics.org.
Thanks a lot, Chris.